A hypothesis is a statement which is about to be studied at the beginning of a statistical investigation.
The hypothesis is then tested to find out how probable the statement is.
The more elements or pieces of data there are in an investigation, the more accurate or valid the results become.
So let's look at two hypotheses. My hypothesis is that heavier birds have longer wings.
And my hypothesis is that heavier birds fly faster.
So let's look at the data. We took 8 birds at random: the duck with its mass, wingspan and maximum speed, the magpie, the nightingale, the pheasant, the puffin, the robin, the vulture and the woodpecker.
But how can we find out whether the statements are true or not? It's best to put all the data into a table so that we show it in a scatter diagram. Scatter diagrams are used to represent and compare two lines of data. By looking at the scatter diagram, we can see whether there is any connection or correlation.
So each axis of the scatter diagram is used to represent each of the data values. In the first example, the mass of the bird is on the x-axis and the wingspan is on the y. After plotting the points and the line of best fit, our scatter diagram looks like this. The scatter diagram indicates positive correlation since the general trend is low left to high right.
Spearman's rank correlation coefficient is a way of putting a numerical value to show how close points are to the line of correlation. To set this value, you need to first rank each set of data, then find the difference between the two ranks. This difference is then squared and all of them added together. This gives the sigma d squared value in the formula.
The heavier birds have a longer wingspan, so my hypothesis gives a value of 0.98.
And the heavier birds fly faster hypothesis gives a value of 0.29.
But what do these values mean? This numerical value correlation coefficient will be between +1 and -1, where +1 is totally positive correlation, 0, which is absolutely no correlation, and -1 indicates total negative correlation.
These figures indicate that in the sample we've used, that heavier birds have a longer wingspan because our correlation coefficient is positive and quite close to 1, showing a high positive correlation.
The figure for heavier birds fly faster indicates a very small positive correlation because the correlation coefficient is positive but is very close to 0.
But do these results prove or disprove our hypothesis, or only show an indication?
Studying statistics at GCSE level will help you understand this deeper question.
On that thought, back to the studio.